Hi students, in this video, let's learn the Chinese remainder theorem and applications of the same. Now let's see an example of a question where this theorem becomes very handy. Say you're given this question 131313 up to 300 digits. So that's a 300 digit number. When you divide this number by 99, we are asked to find the remainder. Alright, now let's see how we can apply the Chinese remainder theorem to solve this type of a question. Alright, the first step is you look at the remainder. Over here you have 99. Let's factorize it in such a way that the two factors obtained are co-prime. So I can write 99 as 9 into 11, right? And we can see that 9 and 11 are co-prime. And remember, co-prime numbers are numbers which have no other common factor other than 1. Alright, now let me denote this 300 digit number as n. Alright, now what we are doing over here is we have factorized the denominator. Let me write that over here. We have factorized the denominator, and the next step is we are going to check if you divide n by each of these, like if you divide n by 9 and if you divide n by 11, what's the remainder that you get? Alright, now over here let's start with 9. We know that whenever you divide a number by 9 and if you want to find the remainder, all you need to do is you need to find the digit sum, right? Alright, so we can see that over here 1313 is getting repeated, right? So if you just take one set, 1 plus 3 is equal to 4, right? So 1 plus 3 is equal to 4, and you will have 150 such sets, right? There are 300 digits. In one set you need 2 digits. Now if you have 300 digits, you will have 150 sets, right? So the digit sum of this number is equal to 4 into 150, right? Every set, the digit sum is 1 plus 3, that's 4, and you have 150 such sets. So the digit sum is 4 into 150, that's equal to 600. Now if you add the numbers in 600, 6 plus 0 gives you 6. So the digit sum over here is 6. Therefore we know that if you divide 1313 etc up to 300 digits with 9, you will get a remainder of 6. Therefore I can write n is equal to 9a plus 6. That means n is some multiple of 9 plus 6, and that's true because we're getting a remainder of 6 when we divide n by 9. Alright, now let's do the same with 11. What's the rule for 11? Let me write the number over here. So you have 1313 etc, and it will also end in 13, right? Up to 300 digits. For the divisibility rule of 11, we have to give plus and negative signs in an alternating manner starting from the right to the left, right? So over here you have a plus, over here you have a minus, you have a plus over here, you have a minus over here, and that goes on, right? And you can see that in one set, right, there is a plus 3 and there is a minus 1. So plus 3 minus 1 gives you 2, and we have seen there are 150 such sets, the same as what we have taken over here. So the digit sum of this, when you apply the signs, will be 2 into 150, right? Each set has a sum of plus 3 minus 1, that's 2, and you have 150 such sets. So 2 into 150 gives you 300. Now over here you can see that when you divide 300 with 11, you will get a remainder of 3, right? You can also try it like this. You give a plus over here, a minus over here, and a plus over here. So that's 3 minus 0, and that's equal to 3. Therefore n can be written as 11b plus 3. Alright, let me summarize. The first step is we factorized the denominator and we wrote it as a product of numbers that are co-prime. So 99 was written as 9 into 11. Now the second step, we found that if you divide n, the given number n, with 9, you get a remainder of 6, and to find that we calculated the digit sum. And the third step, we saw that n is equal to 11b plus 3. That is, if you divide n with 11, you will get a remainder of 3, and we use the plus minus rule to find that, and we have seen that over here. So let's write our findings over here. We know that n is equal to 9a plus 6, and we know n is equal to 11b plus 3. Let me write it together. So n is equal to 9a plus 6 is equal to 11b plus 3. Now this over here represents an arithmetic progression. Let's try to understand it in a better manner. For that, we'll try to solve and get one solution of a and b. Alright, now let me write 9a is equal to 11b plus 3 minus 6. So I take this to the right hand side. So 9a will be equal to 11b minus 3. Now 11b, I can write it as 9b plus 2b, right? Okay, and let me take this 9b to the left. So I can get 9a minus 9b is equal to 2b. That's what remains over here, 2b minus 3. Now a minus b, let me take it as x. So the left hand side becomes 9x. 9x is equal to 2b minus 3. And from here I can find that one solution where this is valid is when b is equal to 6, right? When b is equal to 6, you get 2 into 6, that's 12, and 12 minus 3 is 9, right? And in that case x is 1. So one solution where this is satisfied is b is equal to 6, and you find this with trial and error. You just try numbers like 1, 2, 3, etc. So at 1 it's 2 minus 3, it's minus 1, so that doesn't work. At 2 it is 4 minus 3, it's just 1. At 3 it is 6 minus 3, that's just 3. At 4 it is 8 minus 3, that's 5. At 5 it's 10 minus 3. At 6 you will get it's 12 minus 3, which is equal to 9, and there you can see that that's satisfied when x is equal to 1. So find any one solution. Alright, so we have that over here. Let me summarize it over here. We have our AP as 9a plus 6 is equal to 11b plus 3, and we have seen that one solution of b is equal to 6, right? Now let me write the solutions over here. That's b, that's a, that's n. Now we have seen one solution of b is 6, which is what we have got over here. Now in this equation over here, 11b plus 3, let me substitute b is equal to 6. I'll get 11 into 6 plus 3, that's 66 plus 3, which is 69. So that's the solution of n when b is equal to 6. And we know that 9a plus 6 is equal to 11b plus 3. So this 69 over here will be equal to 9a plus 6, or you can see a is equal to 7. So let me write that over here. So we have got one set of solutions. Now in this type of an equation, you can see that the solutions move in an interesting pattern. If you want to find the next solution of a which is valid for this equation, it will move in steps of 11. The next solution of b will be in steps of 9, and the next solution of n will be in steps of 99. So what do we mean with that? If you want the next solution of b, you have already 6. The next one would be 6 plus 9, that's 15. And the next one would be 15 plus 9, that's 24. So these are some of the solutions of this equation. Now at b is equal to 15, you will get a different a and n. And over here you can see a moves in steps of 11. So basically a moves in steps of 11. You can see that 11 is the coefficient of b. So a moves in steps of 11 and b moves in steps of 9, which is the coefficient of a. Alright, so the next solution of a will be 7 plus 11, that's 18. And the next one would be 18 plus 11, which is 29, and it goes on like that. And n moves in steps of 99. So over here you have a solution 69. The next solution will be 69 plus 99, which is equal to 168. The next one would be 168 plus 99, which is 267. The next solution will be 267 plus 99, which is 366, and it goes on like that. Alright, now you can see that the number that we are given over here, 1313 etc. up to 300 digits, is part of this AP over here. Let me write that over here. So you have an arithmetic progression over here with a common difference of 99. You have 69 over here, you have 168 over here, 267 over here, 366 over here, and it keeps going on in numbers where you get 9. If you add 99, you'll get the next one. So the next one would be 465, right? And the next one would be 564, and it goes on like that. Now after you go a considerable length, you will get n also in this arithmetic progression, and that's what we learned from the Chinese remainder theorem that n will also be part of this arithmetic progression. Now we know that in any arithmetic progression, if you take any term and you divide that term with the common difference or with a factor of the common difference, the remainder will be the same, right? We have learned that already. So applying this rule, we can see that if you divide 69 with 99 or you divide n, that's this 300 digit number, with 99, your remainder will be the same. Let me write that over here. So 69 by 99 remainder is the same as n by 99 remainder, and we can see that 69 by 99 gives you a remainder of 69 itself, because 69 is 0 into 99 plus 69. Hi students, let's try to do this question. Pause the video, give it a try, and then we'll do it together. Alright, I hope you have given it a try. We have already discussed the Chinese remainder theorem, which helps us to solve these type of problems. Now remember what we are trying to do when we apply the Chinese remainder theorem. Let me write it as CRT. Is we are going to find an AP, right, such that there will be other terms which are much smaller than this. So if I call this as n, say I call this number as n, I want to find an AP in which n is part of the AP. So for example, I find A, B, C, and then I'll see that n is part of this AP. Once I have found this, I can confidently say that if I divide A or B or C or n with the common difference or a factor of the common difference, the remainder obtained will be the same. And it's very difficult to do. Say for example, the common difference, let me write it as CD. A by CD will give me the same remainder as n by CD, right? Now to do this is very difficult. So instead of doing this, I'll just do this and get the answer from that. So that's the approach we are going to follow. Let me make some space over here and let's try to do it together. The first step is look at the divisor. The divisor over here is 56, right? Now we need to write 56 as the product of two numbers or more as we can. If you want, we can write it as the product of three numbers also. Over here we can easily write it as the product of two numbers which are co-prime to each other. So 56 is equal to 7 into 8, right? And you can see 7 and 8 are co-prime. Now the approach is that we have to write this n over here as some multiple of 7 plus the remainder that you get in this case, and you also have to write n as a multiple of 8 and the remainder that you get in the case of 8. Now when you equate these two, 7a plus r1 equal to 8a plus r2, this is an equation of an arithmetic progression in which n also will be part, right? So that's the approach. Now let's do it in detail together. First let's start with 8. We know that the divisibility of 8 only depends on the last 3 digits, right? Therefore, if I want to divide n and by 8 and get the remainder, I just need to divide the last 3 digits. That's in this case the last 3 digits will be 1, 2, 3 itself, right? Because over here you can see 1, 2, 3, 1, 2, 3 gets repeated and you have 300 digits. So there will be 100 groups of 1, 2, 3 and the last group also will be 1, 2, 3, right? Therefore, if I want to find the remainder when you divide by 8, you just need to divide 1, 2, 3 by 8. So 1, 2, 3 divided by 8 gives you a remainder of 3. Therefore, I can write n as 8a plus 3. Alright, now let's try what remainder we will get if we divide n with 7. Now let me write the number over here. Now we know that 10 to the power 3 divided by 7 gives a remainder of minus 1, and 10 to the power 6 divided by 7 gives a remainder of plus 1, right? Now because of this, over here we have 10 to the power 3. Therefore we divide this number into triplets, sets of 3 digits at a time, and over here we give a positive sign, over here we give a negative sign, and we do that throughout, right? That's what we learned in the divisibility test for 7, right? And the reason is one over here, see in the expanded form, let me just quickly revise. this part over here is 123 into 1000, right? And over here you can see 1000 by 7 gives a remainder of -1. That's why instead of this we are replacing it with -1, right? All right, now for a detailed explanation of this, check the video on the divisibility rule for 7. Now let's proceed. We move ahead with checking the remainder that we get when we divide n with 7. We have split the number into triplets, 3 numbers at a time, and we have alternated between plus and minus signs over here. Now you can see that in one group there are 3 digits, right? And we are given 300 digits, right? Therefore there will be 100 groups, right? It's mentioned 300 digits. Now in this 100 groups, 50 will get a positive sign and 50 will get a negative sign, right? You can see that over here. If there are only 2 groups, one is getting a positive sign and one is getting a negative sign. Similarly, if there are 100 groups, 50 will get a positive sign and 50 will get a negative sign. Now when we add this up together after applying the signs, it will be of the form plus 1 2 3, minus 1 2 3, plus 1 2 3, minus 1 2 3, etc., right? And you can see that these cancel out each other. So the 50 plus and the 50 minus groups cancel out each other, and the sum that you get when you apply these signs will be equal to 0, right? Therefore that means the remainder when you divide n with 7 is equal to 0. Therefore n can be written as 7b. All right, having established this, let's summarize. We have found that n is equal to 8a plus 3 and n is equal to 7b. Now over here both are n, so I can equate these. So 8a plus 3 is equal to 7b, right? All right, now 8a can be written as 7a plus a. So let me take 7a to the right hand side and I'm left with a plus 3 on the left hand side, and over here say let me write it as 7x. So x is b minus a, right? I don't need to write exactly this. I'm just writing it as x over here. All right, now I just need to find one solution that satisfies this over here. You can easily see that when a is equal to 4, 4 plus 3 is 7. That's a multiple of 7, right? Over here you just need any multiple of 7. So I can give the value of 1 to x. So when a is equal to 4, this is satisfied. Therefore a is equal to 4 is one solution. All right, now let me write that over here. A is equal to 4. When I apply this over here, 8 into 4 is 32. 32 plus 3 is 35. So 7b is equal to 35, right? So b will be equal to 5. I have one solution of a and I have one solution of b. Now at these points n is equal to 32 plus 3, that's 35. All right, now we have seen that a will move in steps of 7, which is the coefficient of b. B will move in steps of 8, which is the coefficient of a, and n will move in steps of LCM of 8 and 7, which is 56. Because we are taking 8 and 7 in a manner that they are co-prime, the LCM always will be 8 into 7, and in this case it will be 56. All right, now let's come back to the question. We just need to find the remainder when n is divided by 56, right? Now we, as per the Chinese remainder theorem, we know that n will be part of this AP, which is this one 35. The next term will be 35 plus 56, which is 91. The next term will be 91 plus 56, which is 147, and it goes on like that. And finally you will get n over here also, which is a 300 digit number, right? Okay, so and as per the constant remainder condition in an arithmetic progression, we know that if we divide 35 with the common difference and if we divide n with the common difference, the remainder will be the same. Therefore 35 divided by 56, 56 is the common difference, remainder is the same as n divided by 56 remainder, which is what we need to find out, and this over here is equal to 35, which is our answer.